Morning or afternoon class. I'm not really sure when this will be presented, but today I'll be presenting on holographic imagery. So holograms are mostly used, or more commonly used, in movies to signify a leap in technological advancement. So what is a hologram? So a hologram is a three-dimensional image formed by the interference of light beams from a laser or other coherent light sources. In addition, it can be a photograph of an interference pattern which, when suitably illuminated, produces a three-dimensional image. The process of recording objects to create holograms is also known as holographic imagery or holography, which is a unique form of photography whereby 3D objects are recorded using a laser and then restored as precisely as possible to match the original recorded object. When illuminated via laser, holograms are able to form an exact 3D clone of the object and duplicate its features. So if you were to record a laptop, right, using the process of holography, and then you illuminate it with the laser, that recorded object will present a three-dimensional figure of the laptop. Before I get into how this all works, allow me to talk about the father of holography, Denis Gabor. Denis Gabor is the father of holography. He was a Hungarian-born electrical engineer and a physicist who invented holography in 1948 and received the Nobel Prize for Physics more than 20 years later in 1971. He explained his discovery as a new method for forming optical images in two stages. In the first stage, the object is lit using a coherent monochrome wave, and the diffraction pattern resulting from the interference of the secondary coherent wave coming from the object with the coherent background is recorded on the photographic plate. If the properly processed photographic plate is placed after its original position and only the coherent background is lit, an image of the object will appear behind it in the original position. In simpler terms, a laser is shown into a specialized mirror called a beam splitter, which creates two separate beams. The first beam, the reference wave, went in a horizontal direction and hit the photographic plate and would be registered there as an interference pattern of light waves. The second beam, the object wave, went in a 90-degree angle and hit a semi-mirror, which is a mirror that's half silver, half black. The beam is then relayed from that semi-mirror onto another semi-mirror, which is also half black, half silver, and is then relayed to an object. After hitting the object, the beam then hits the photographic plate and is registered as an interference pattern, which is then interlocked with the reference wave's interference pattern. The result is the plate now has circulating energy in it, not perceptible to the human eye. And in order to see this stored information, a laser must be shone into the photographic plate. And what is shown is a three-dimensional form of the recorded object. His theory would then go on to inspire the creation of two other forms of holography. There are three main types of holography: reflection holograms, transmission holograms, and hybrid holograms. For reflection holograms, the object and reference beam directed on holographic film is on opposite sides. This type produces high-quality images, thus very expensive. The reflection hologram, in which a truly three-dimensional image is seen near its surface, is the most common type shown in galleries and museums. The hologram is illuminated by a spot of white incandescent light held at a specific angle and distance located on the viewer's side of the hologram. Thus, the image consists of light reflected by the hologram. Recently, these holograms have been made and displayed in color. Their images visually identical to the original object. With transmission holograms, the object and reference beam directed on holographic film is on the same side. It is less expensive if mass-produced. The typical transmission hologram is viewed with laser light, usually of the same type used to make the recording. This light is directed from behind the hologram, and the image is transmitted to the observer's side. The virtual image can be sharp and deep. For example, through a small hologram, a full-sized room with people in it can be seen as if the hologram were a window. If this hologram is broken into small pieces, one can still see the entire scene through each piece. Depending on the location of the piece, a different perspective is observed. Now, hybrid holograms are special, as there is no need for real objects. The interference pattern is calculated digitally using computer algorithms between the reflection and transmission types of holograms. Many variations can be made. One of such is the computer-generated holograms. The mathematics of holography is now well understood. Essentially, there are three basic elements in holography: the light source, the hologram, and the image. If any two of the elements are predetermined, the third can be computed. For example, if we know that we have a parallel beam of light of a certain wavelength and we have a simple hologram, we can calculate the diffraction pattern. Also, knowing the diffraction pattern and the details of the double slit system, we can calculate the wavelength of the light. Therefore, we can dream up any pattern we want to see. After we decide what wavelength we will use for observation, the hologram can be designed by a computer. The computer-generated hologram, or holography, CGH, has become a sub-branch that is growing rapidly. For example, CGH is used to make holographic optical elements, HO, for scanning, splitting, focusing, and in general controlling laser light in many optical devices such as a common CD player. How holograms work. In order to produce an accurate visualization of a hologram at a certain point in space, two light beams must be present: the object wave and the reference wave. Both are formed by separating the laser beam with a beam splitter. The reference wave is created directly by the light source, and the object wave is reflected off the recorded object. There is also a photographic plate, which dark stripes are imprinted depending on the distribution of electromagnetic energy, interference energy in a given place. A similar process takes place on ordinary photographic film. However, to reproduce an image from it, a print out on photographic paper is required. Although during the active use of hologram technology, everything happens a little differently. To produce a portrait, the photographic plate has to be illuminated with another light wave in close proximity to the reference wave, which converts both waves into a new wave of light that runs alongside the object wave. The result is an almost entirely accurate reflection of the object itself. This ties into holographic storage, which is a more modern way of recording holograms. In order to record a hologram, data is encoded in a 2D image using a special light modulator. The beam is then combined with a reference beam inside the lithium nitrate crystal, and the data is encoded as interference pattern. We can record multiple beams simply by changing the angle of the reference beam using a MEMS mirror, allowing us to record many data sets in the same volume. To read out the data, we simply use the reference beam at an angle designed to select the page we want, and that recreates the original data captured, and different pages can be read by changing the angle of the reference beam. We can move to other locations in the crystal to write more data, and the crystal can be completely erased using UV light and write new data. So the uses of holograms are varied. Applications of holography include information storage, recording of images in depth, the use of holograms as optical elements, and as a means of performing precise interferometric measurements on three-dimensional objects of any shape and surface. In the military, it is used for military mapping, as geographic intelligence is an essential part of military strategy, and fully dimensional holographic images are being used to improve reconnaissance. Holography provides better communication for doctors due to the extensive capability of 3D visualization of a patient's body with higher resolution, and can be used to simplify the procedure of complex treatments. And for businesses, for the most part, use hologram technology for large conferences or meetings that require subject matter experts. And yeah, that's all I've got on holograms for now, guys. Thank you for watching and have a nice day. So the uses of holograms are varied. Applications of holography include information storage, recording of images in depth, the use of holograms as optical elements, and as a means of performing precise...
I heard youth. I'm like, wait.
So the applications of holography are varied. These include information storage, recording of images in depth, such as... No, let me not give an example without actually having an example.
cutting it close to where you're going to have to edit this. You know that.
Yeah, no, I'm editing
You're gonna be
this.
cutting this like crazy.
Yeah, I
6
know.
minutes left, man.